Welcome to TED Talks. You are still with me, Mugwanya Simon, and our main focus for now are the classes of amino acids. We have so far discussed essential amino acids versus non-essential amino acids. Let's go to category number 2. Category number 2. So we can have non-polar amino acids. If it is not non-polar, then it is a polar amino acid. What would this mean? Excuse me. It would mean that the non-polar amino acids are hydrophobic. In other words, are insoluble in water. They don't have polarizable groups in. So the R group in the amino acid outweighs the ionizable groups, making the whole molecule non-polar. So we have several examples. Glycine is non-polar, so it means it cannot go into solution. Alanine is non-polar. Tryptophan non-polar. Valine non-polar. We shall come back to the effect of valine when it substitutes glutamic acid in the hemoglobin polypeptide chains. It is non-polar. Proline is non-polar, isoleucine is non-polar, phenylalanine is non-polar, methionine and leucine. So to remember a bit, because it is examinable, to remember a bit and say these are the examples of non-polar amino acids. We have a slogan to help us remember them. It is go and take vital part in promoting matter language, or we can even say in promoting mother language, because that one will sound easier to remember. The first letter corresponding to an amino acid. So we can now see that all the P's this time around are non-polar, proline and phenylalanine. But now the T's are not. Tryptophan is here, threonine is the other side. That is one. Polar amino acids, it means they can go into solution. If you dissolve them in water, they would end up dissolving in water. But among the polar amino acids, the first category are polar, yes, but neutral. Neutral to what? Neutral to litmus paper. Meaning if an amino acid is like this. Now we take an example of cysteine. If an amino acid is like this, when an amino acid is like that, and you dissolve it in water, why does it become neutral? Not even acidic. So, why? This acidic group loses the proton and the basic group absorbs the proton. So they end up being neutral. In addition, they are neutral to litmus paper also neutral in the electric field, in the electric and magnetic field. So when placed in an electric field, it remains undecided, as you are going to see. Then others are charged. These charged amino acids, it means in their R group, if it is a sweet ion and it dissolved in water, we said it is having a positive end and a negative end. But a negative end is cancelling out the positive end. So it means generally an amino acid is supposed to be neutral. But what makes it charged? It means we can find when we have another ionizable group in the R group, in that this negative is neutralized by that positive, but when this one ionizes, the negative now makes it charged. Or it might have more nitrogen in the R group. So meaning the R group on amino acids are the basis of the variation of amino acids, to the extent that some are polar, others are some are non-polar, others are polar. Even amongst the polar, some are neutral, some are charged. So in our subsequent sessions, we shall come back and look at the isoelectric point of a protein, majorly the charged, the neutral, plus the polar.